Hi Physics. We're going to do from homework 5, this is problem 2. We've got Alice and Billy pushing a crate across the frozen lake. The crate's total mass is 90 kilograms. Alice is going to push with a force of 225 newtons, and Billy is going to help by pulling with a force of 175 newtons at an angle of 40 degrees above the horizontal. So Billy is going to be giving us an ugly vector. The coefficient of kinetic friction between the crate and the ice is 0.100. So we want to figure out what is the normal force on the crate, and also what is the acceleration of the crate. So as usual, we're going to start off with a step So we want to make sure we know what we're looking for and what units we expect it to have. So for part A, what is the normal force? So F sub n is equal to question mark newtons. For part B, what is the acceleration of the crate? That's actually going to be acceleration in the x direction. So A sub x is equal to question mark, and its acceleration, so its units will be meters per second squared. So that's our step All year long, the first thing we do after step is step 1, and that is make a sketch. So we need to have a clear picture about what's going on here. So we have some ice, we have a crate, we have Alice pushing on the crate. She's pushing straight to the side, so force of Alice. We have Billy pulling on the crate. He's doing so at an angle. So here's Billy, who's apparently much taller than Alice and wearing mittens. So Billy's pushing over here. That is an angle of 40 degrees. Here's our force of Billy. We know the crate has a mass of 90 kilograms. And we know that there's friction between the crate and the ice. So that means mu sub k, which looks like an m, but it's actually a mu, is equal to 0.100. And we're moving to the right, so we might as well give this thing some speed lines. And I guess Alice gets speed lines too, and so does Billy. So we're all going to the right. So that's our sketch. That's our picture of what's going on. The next thing you do, and actually I think I'm going to do this on a new screen. The next thing you do is step 2. So step 2 is a free body diagram. So the crate is now a box. Well, that's convenient. The crate is a box. It's near the Earth, so we know that there is a force of gravity going down. The crate is touching the ice, so we know that there's a normal force from the ice on the crate. It's moving to the right, which means there must be friction to the left. So force of kinetic friction to the left. Alice is pushing to the right. So here is our force of Alice. Billy is pulling upwards and to the right. So he's giving us an ugly vector. We've got something like this. I'm sorry, not F sub n. F sub b, force of Billy. So this is all correct. However, Billy is giving us an ugly vector. So we have to do something with that ugly vector. So we're going to go take this guy here, and we're going to do a step 0 to our ugly vector. So step 0 is find the components. So the ugly vector we're starting with, something like this. So it's 40 degrees, which is less than 45. So I'm going to draw it so that I'm sure that it's less than 45. We have force of Billy, and that is 175 newtons. So I need to know how much of that force is going to the right and how much of that force is going up. So how much it's going to the right is going to be F sub b x. How much it's going up is going to be F sub b y. If I look at this real quick with the trig, this side is definitely the hypotenuse. This bottom side, F sub bx, this is the side that is adjacent to the angle. So this one gets an A. That means this other side here must be the opposite. So that one gets an O. So if I'm doing this, let's see. I've done enough of these problems that I know the side with the adjacent, that has to be f sub b times cosine of theta. And this other guy over here, f sub by, well, that's dealing with the opposite side. So that must be f sub b times the sine of theta. So f sub bx, that's going to be, f sub b is 175 newtons. Sorry, that's 175 times cosine of 40 degrees. If I ask my calculator what that's equal to, I'm going to end up with f sub bx is equal to 134.1 newtons. I'll circle that because that's important. Over here on the y side, f sub by is equal to, f sub b is 175 newtons times sine of 40 degrees. I asked my calculator what that is, and my calculator tells me that that is 112.5 newtons. So I'm going to circle that too. And if I look, this does pass the small, medium, large test, because my smallest number, this one here, that's going on the smallest side of my triangle. My medium number is this one here, that's going on the medium side of my triangle, and my largest number, that's going on the hypotenuse. So that's a good clue that I've probably done my trig correctly. So now that I've done all this to my ugly vector and I found two pretty components for it, I'm going to go back and do a new step 2, this time only with the pretty components. So here's my box again. The vectors that were already pretty, those get to stay just the way they are. Normal force, that was fine. Force of kinetic friction, let me fix that. Sorry, I'm drawing with my fingertip. It's not working out perfectly. So that's okay. We have force of gravity going down. We have force of Alice to the right. That vector was already okay. And now the whole point of doing the step 0 is instead of drawing this ugly vector again, I'm going to replace it with its two pretty components. So that's going to give me f sub bx to the right and f sub by going up. So I've got those guys. So that is step 1, step 2, step 0, step 2 again. And I'm going to stop this video here and do a separate video where I finish this problem because I don't want these videos to get too long. Hopefully that helps.